Good afternoon, Chairman, fellow speakers, experts, ladies and gentlemen. I'm Sophie Tam from Hong Kong, representing Sound Blast Sonic Power Company Limited. It gives me much pleasure today to be here to discuss with you all performance improvement through sonic suit blowing. Now, before I begin, we'd like to congratulate CII for organizing a most successful international technical conference, Power Plant Summit 2013, and we wish our stakeholders, designated consumers, and participants continued successes. So if you're a PAT scheme Phase 1 designated consumer, DC, in thermal power plant sectoral, ask yourself, what have you done in the past 15 months and 26 days to be exact, since March 30th, 2012, to reduce your specific energy consumption, SEC, to meet target value? To those who forgot, March 30th, 2012 was the day Indian Ministry of Power gazetted notification on PAT scheme Phase 1 and announced DCs in 8 industrial sectorals to reduce SEC to target value within 3 years. So that's 2015. And now that this conference coincides with Phase 1 countdown midpoint, is an interesting, gentle reminder to you all to well look after your plant performance as well as your wallet. And in simple terms, plant performance improvement is closely related to PAT scheme. How? Because plant performance improvement implies SEC reduction at rated production volume. It is often noticed that SEC value lowers as soon as plant performance improves, coupled with reductions in human resources involvement, consumption of installation hardware, and operation downtime. Once a plant runs smoothly, effectively, and efficiently as designed and intended, following observations become very logical. Now, plant performance improvement is inversely proportional to SEC. So that means when your plant performance improves, your SEC value lowers. And number 2, plant performance improvement is directly proportional to internal cleanliness of installations given other conditions are equal. So in simple terms, if the inside of your installations are clean, so plant performance improves, and then your SEC lowers. However, for one reason or another, there are plants which operate far away from design parameters, and most are now marked as DCs in PAT scheme Phase 1. In the following slide, I'm going to show you a distribution curve of the 144 DCs in thermal power plant sectoral. And this distribution curve will show you how far away the DCs deviate from the SEC target line, which the ministry draws for them to achieve in 3 years. So this is the thermal power plant DC distribution curve. Each red dot represents 1 DC. And the x-axis, the line, horizontal line, represents the SEC target line. The main takeaway from this curve is to see how far away the red dot is from the SEC target line. And that means how much they need to catch up with to touch base. We also did another analysis, economic value quantum distribution. Now, economic value quantum distribution is another perspective representing DC's deviation from target. How we calculate that is defined as annual production volume multiplied by your SEC deviation. And the economic value quantum distribution shows where the DCs stand relative to the SEC target at 0-0 conjunction of the XY axis, which I'm going to show you the graph now. Now you see here, we have zone A, B, and C. Zone A lies closest to the 0-0 junction of the XY axis, and therefore we say the DCs in zone A have less to catch up with to touch base. And in Zone C, if you're a DC and your plant lies in Zone C, you must work harder to meet the set targets. But for top management, SEC remedial standards set too high and difficult to attain. In most cases, plant SEC reductions can be achieved through simple and straightforward performance improvements, such as sonic soup blowing. Successes in SEC reduction, of course, relate to specifics of individual plant. What then is performance improvement of a plant? We have two definitions for performance improvement of a plant in the overall sense. Definition number 1, plant performance improvement is a summation of reductions in SEC value, human resources involvement, hardware consumption, and downtime. And definition number 2, plant performance improvement is equal to the sum of performance improvement of individual installations. Following from definition number 1, once a plant operates effectively and efficiently, energy extraction from a given amount of fuel input will be maximized and overall plant SEC minimized. That human resources involvement will be reduced, and there will be less hardware consumption and downtime. But what if the plant is not operating at par presently and SEC still stands high with only 20 months to go? What do we do? Our definition number 2 provides that plant overall SEC can be accrued from individual installation improvements. And therefore, as soon as small and reliable investment programs to produce sustainable, quick results are implemented in selected installations in the remaining 20 months to the end of PAT Phase 1, it is still very hopeful to meet overall plant SEC target before penalty time. And this is similar to calling in the US Navy SEAL to rescue. Sonic soup blowing is a well-proven, small and reliable investment program to produce sustainable, quick results in thermal power plant installations. Needless to say, the first step in plant performance improvement is to ensure that the boiler is always clean and at tip-top condition, since it is our number 1 and only tool to release energy locked inside fuel, and therefore justifies our full attention. But by tradition, most boilers are cleaned by steam soup blowing, with much room for improvement. In this case, it's time to consider sonic soup blowing. Sonic soup blowing cleans at over 100 cleaning cycles daily and uses low-pressure plant air to drive, so that it is far more superior than steam soup blowing for on-load cleaning of boiler tube packages, ESP plates and wires, baghouse filters, ID fans, large trunks and ducts, etc., i.e., installations prone to foul and lead to more serious issues in thermal power plant. Now here is a great comparison between the steam soup blowing and the sonic soup blowing. You can see the timeline from 0 hour to 8 hours. And within these 8 hours, the steam soup blowing on the top, it only has 1 cleaning cycle in every 8 hours. But then look at the green line, sonic soup blowing. It has over 32 cleaning cycles in every 8 hours. And in other words, it can clean like 15 minutes in every cleaning cycle. Sonic soup blower is easy to operate and maintain. This picture here shows you the relative size of Era SB and sonic soup blower with similar cleaning range. You can see there's a very big size difference here. Driven by 7-bar plant air, Sonic Soup Blower is simple, user-friendly, easy to install, and requires almost zero inspection, maintenance, and repair. You can see from the picture here and also in our product outside, the diaphragm is the only moving part, and it shows you what it means by simplicity equals to reliability. So how it works? Sonic Soup Blowing uses sound energy sent inside an enclosed space to fluidize small particulates, which jump away from surfaces and are carried off by flue stream, leaving the surfaces clean. Sonic Soup Blowing cleans on load in short on and off cycles continuously 24 hours daily, with on time in seconds and off time in minutes. Cleaning time is adjustable. On time can be shorter if small particulates are easier to remove, and off time must be short if inlet dust loading is high, and vice versa. Limitations. Sonic Soup Blowing is not a panacea for all fouling cases. There are 4 situations where it cannot clean at all. Number 1, slag. Number 2, clinker. Number 3, very sticky ash as in APH. And number 4, wet surfaces. Otherwise, it can take on almost any cleaning job.